Okay, we are going on with 1.3 notes. So this is the second part of 1.3 notes. We're talking about distance now. Okay, so the distance formula, big square root, x2 minus x1 squared plus y2 minus y1 squared. So what I tend to do is I'll write my points out first. So negative 2 comma 4 is the first point I see here. 1, 3 is my second point that I see. So this is my x1 and my y1 because I just see that point first. So this is my x2 and my y2 because I see that point second. It really doesn't matter which order it is, just as long as whatever you use for your y2, like if I use 3 for my y2, then I have to use 1 for my x2. So I'm going to plug this in. x2, so 1 minus a negative 2, so that really becomes plus, squared, plus y's 3 minus 4 squared. So 1 plus 2 is 3, 3 squared is 9. 3 minus 4 is negative 1 squared is a positive 1, so that's plus 1. So really we're doing the square root of 10. It tells me to the nearest tenth. It may also want you to reduce this radical. So we went over how to reduce radicals at the end. If I reduce this, it goes 5 and 2. It doesn't reduce, so that would be your reduced radical answer. If I bring this to the nearest tenth, it's 3.16. So that would really be 3.2. All right, let's try the next one. I'm going to use 4 as my point 1 and 2 negative 1 as my point 2. You can do this. If you want to stop, pause, and use this as your first point and this is your second point, you'll see you'll get the same answer as me in the end. Okay, big square root, so x2, 2 minus 4 squared plus negative 1 minus 4 squared. So 2 minus 4 is negative 2. Negative 2 squared is a positive 4 plus negative 1 minus 4 is negative 5. Negative 5 squared is 25. This is square root of 29. That is the reduced answer on that, or the decimal answer is 5.4. Go ahead and pause me, and I want you to try 18, 19 on your own, and then unpause me when you're finished. So I'm going to use negative 2, 3 as my point 1, 2, 1 as my point 2. So this is big square root. So this is 2 minus negative 2 squared plus 1 minus 3 squared. 2 negatives make a positive. So big square root, 2 plus 2 is 4. 4 squared is 16. What an awesome game. 1 minus 3 is negative 2. Negative 2 squared is 4. So this really is square root of 20. Reduce down, that reduces into 4 and 5, 2, 2, and 5. So I have a pair of 2's. 2 comes out, 5 stays under. So 2 square roots of 5, or square root of 20 is 4.5. All right, one more. Point 1, point 2. So big square root symbol, x2, 2 minus 10 squared plus negative 3 minus 5 squared. 2 minus 10 is negative 8. Negative 8 squared is 64. Negative 3 minus 5 is negative 8 again. Negative 8 squared is positive 64 again. So that's the square root of 128. This breaks down into 64 times 2. Square root of 64 is 8, so it would be 8 square roots of 2. Or second square root of 128 is 11.3. All right, so that's how you use distance formula. These could have been done by Pythagorean Theorem also. Oops. Well, that one's more difficult. If I look up at this one, if I make the right triangle, Pythagorean Theorem would have said a squared, which is 2 squared, this piece, 1, 2, 3, 4, 5, plus 5 squared equals this c squared. So that's 4 plus 25, which is essentially what you did in here. And then take the square root of that. Okay, find the length of the segment, then find the coordinate of the midpoint of the segment. So you take your last number minus your first number. 2 negatives make it positive, so the length is 9. If I'm going from negative 3 to positive 6. Half of 9 is 4. Sorry, half of 9 is 4.5. So to find the midpoint, I would go back 1, 2, 3, 4.5. So the midpoint is at 1.5. The length is 9. Here, -1 minus -8 to find the length. So that's a length of 7. I divide that by 2 to find the midpoint, which is 3.5. That means I go back 1, 2, 3.5. That does not mean that 3.5 is my midpoint. That doesn't make sense as an answer, right? So that is at -4.5. That is your midpoint. All right. The endpoints of two segments are given. Find each segment length and tell whether they are congruent. Okay, so essentially you're just doing a couple distance formulas here. So I'm going to start with AB, big square root, and do x2 minus x1 squared plus y2 minus y1 squared. That's -2 squared, which is 4, plus 3 minus 6 is -3. -3 squared is 9. That's the square root of 13. I'm going to leave it like that. That's reduced radical. CD, 1 minus -1, so 1 plus 1 squared plus 3 minus 0 squared. So 1 plus 1 is 2, 2 squared is 4. 3 minus 0 is 3, 3 squared is 9. That is the square root of 13. So yes, they are congruent, meaning they have the same length. I would say AB is congruent to segment CD. Go ahead and pause me. Try 23 on your own. Unpause me when you are finished. So here RS, y2 minus y1 squared plus, or sorry, that's x, y2 minus y1 squared. 0 minus 5 is -5. -5 squared is 25. 4 minus 4 is 0. 0 squared is 0. So square root of 25 is just 5 for RS. TU is -1 minus -4, so plus 4 squared, plus 1 minus or plus 3 squared. -1 plus 4 is 3. 3 squared is 9. 1 plus 4. 1 plus 3 is 4. 4 squared is 16. 9 plus 16 is 25. Square root of 25 is 5. Hopefully I didn't make a mistake in my math here. So RS is congruent to TU. They are congruent. I think that's all of them. That was a lot, wasn't it? All right. That is all of those notes for now. Just let me know if you have questions on any of that. Thanks, guys.